everybody? How are you all doing today? Back again with a bit more of the Unreal Engine 4, where my friends Train Bro Jim and I are going through the documentation in order to learn how Unreal Engine works. We're still working on with the audio segment. Today we are gonna be looking at audio streaming caching device. And right now I'm just waiting on him to finish up. Once he finishes up, we'll be hopping up on to his um onto his stage, and we'll get the session started. Right now, my friend's doing the Pega certification lessons, and since there is a bit of a delay, I just gotta wait a little longer and see if he's already done with that. Let's see. What can we talk about while we wait? Let me switch back to that. It does seem that there's not much left. Like, this one has quite a bit to cover a bit, but there's not really that much left. I mean, there's 1, 2, 3, 4, 5, 6, 7 left. I'm only hoping that they're just not that long. For those that are watching this and haven't watched the other parts, I don't delete any of my VODs. All my VODs of everything I've covered with my friend will all be there. It is my friend mainly the one reading out what's here, mainly because, well, my English is not my main language, it's more my second language, and he can read better than me this stuff. And we don't expect us to understand the audio part very well. We are not like audio engineers. We are mainly like programmers, so the sort of audio stuff is really hard for us. But once we are gone through all of this audio stuff, we'll hop on to the next section of the Unreal documentation, which was let me remind myself. What was the next part? Was it AI? The next part we were gonna cover. Just give me a second. I need to find a list real quick. Because we do need to cover AI. We need to cover physics. What else do we need to cover? Here it is. Okay, yeah, next up will be AI. Then it'll be physics, then game controls, animating characters and objects, object collision, blueprints, level transition. Then determining what platform we're gonna be uploading our stuff. Will be Steam, itch.io, Game Jolt, or I don't know, mobile, which I'm not really looking much on that side. I'm more of a Steam and itch.io. More itch.io, since we can get more player feedback from there when it comes to indie devs. Then we'll be deciding which what are the games we're gonna make, starting off with some form of a clone of something that's already out there, and then we'll move on to the UML stuff, which is the last on the list. It seems like my friend's getting ready. Okay. And I'll wait till I see that he's starting soon. I need to make sure, okay, both my audios are open, both my mic and my desktop, so you guys can hear it. I don't put music like I do on my Blender and Krita streams because I'm afraid that it might be a little too loud for you guys to hear him. So both of those audios will go through the desktop audio part. Okay, he's almost ready. So I'm not putting any music yet here on this thing. Will I put music later in the future? I don't know. It depends. Once we get to the whole making a game, how much talking to each other there will be. These sessions are always like a 1 hour long thing, so. And after that, I stop, go get some meat, some tea, and then I move on to my gaming streams. And okay, hopping on to his stage. And let's see, while we wait for him, what can we...
Hey there, Blackheart. Give me a minute.
No, there he is.
Gonna make sure that we do I do a proper intro on this video. So
I'll let him do that, and I'm gonna be quiet so you guys can also hear it.
Right there with you.
Man, my headset was a little bit loud. Kinda heard him a little too loud on my ears. Hopefully the volume I set was good. And hopefully you guys can hear him too. If it is a little low, let me know so I can adjust the volume a little bit more. Hopefully I can fix that without screwing too much on the audio for the games. I did lower the desktop audio because some games were a little too loud.
Get started on this there, folks. Oh, wait, I don't have the wrong... I have the wrong scene collection. Hold on, be right back. There we go, and why is it not showing the page? Probably because the page changed, so let's go ahead and fix that. There we go. Awesome. There we go. We're back in business. So, we're going to be getting started here with the Unreal Engine here in just a minute. I'm your host, Strange Road Jim. We're going to be continuing on with our studies on the audio systems. In particular, we're going to be covering the audio system caching overview today. So, they'll be prepared for that. Got Blackheart in the stage, so let me go ahead and invite him to speak. There we go.
Hello there, Jim. How you doing?
Not bad there, bud. How about yourself?
I'm doing okay. Surviving the heat.
I'm trying to survive the cold. Okay, so yesterday we finished off the quartz overview. Obviously we skipped a little bit of the ending there because it was basically like a it was talking about how to put quartz into the application, and well, we don't really need to worry about that
Not yet, at
too
least.
much until not yet, at least, until we can, once we get to a clone and start working on our own project, then we may need to worry about it. But for right now, we're gonna leave it alone for now. So next topic here is the audio stream caching overview, and when we were looking at it yesterday, there was a lot of seemed like it was also like quite a bit in terms of here's how to do here's what you need to do in order to set things up. So I don't know how much explanation that they're going through on this one, but I'd say we'll have to see. This might be a little too much hands-on work than actual explanation potentially. Um, so we'll see.
Yeah.
Uh, Now, just as a heads up, any, or have you gotten any kind of like comments or questions or anything along those lines through any of your videos at all, or
Not yet. At least not for this stuff.
okay, that's that's okay. I just want to ask and all that. Neither have I, so but obviously we want to encourage anybody that wants to maybe help us out or correct us or um, maybe add some additional information, whatever. We are um, very much into any kind of assistance along those lines. Um, so I mean, feel free to go to either one of our videos or both, and add those comments in if you want to. Or go to our chats when we're live during this and chat with us there. um but shall I get started on this topic?
Yep.
At least try to. Okay, so the audio stream caching significantly changes the way audio is loaded and released from memory. When this feature is enabled at cook time, okay, interesting phrase there, almost all compressed audio data is separated from the used sound wave asset and placed at the end of the .pack file. Okay. Separate from the used sound wave asset and placed in the end of the pack file. Weird that they are like you're taking all this compressed audio data from an asset and you're putting it into a file. You would think that it would be kind of like the other way around. You would think that they would be taking information from a file and put it into some form of asset to be referenced during a game. So this seems very backwards in my mind right at the moment.
Yeah, I don't know really.
Yeah, not sure. It's feels very odd right at this moment in time, but I mean, again, we're just like 2 sentences in, so who knows? This makes it possible for audio to be loaded into memory at any point and released again when it has not been recently used. Again, seems very backwards, in my opinion. Like, you would think that you would take, audio from the files, from an audio file, and place it into, like, some stored memory or some like cache memory or something like that, so that you can kind of use it at any point. So unless the pack file is somehow cached, but I don't.
Maybe a form of cache.
Maybe, but again, seems I've never heard of cache being with specifically lined up with a file before. So I've never heard of a file and cache being aligned with each other, because typically cache memory doesn't really have a lot of space to it. You just want to send data to it fairly quickly, so that it can process it and then send it right back out again. It's not meant to be like a permanent kind of source of memory. So whenever I see a pack, that kind of gives me more of a sense of, permanence to it. So that's why it's like, that's a little weird. But again, I don't know. I don't know what they're doing here. So, um, this method of memory management is popular for open world games, where the actual audio needed for a specific use case is difficult to determine ahead of time. The primary disadvantage of this method is that just because new sound wave is loaded, this does not guarantee that the audio will be immediately playable. However, the benefit of a system that lets designers reference as many audio assets as they want without overstepping memory boundaries. The system also provides a way for engineers to load and reference chunks of compressed audio without relying on the state managed by the audio engine. Also, mitigating latency when playing back audio with the stream cache is easier than mitigating memory issues without the stream cache.
So it's more of an open world use, this. I guess for open world it would make sense to use something like this. I mean, you never know exactly where the player's gonna go at all times, but you gotta have the audio ready at all time.
Well, yeah.
But if it was something more linear, and then you have more control when the audio is loaded.
Yeah. I guess I'm just kind of caught up with the beginning, with like that second paragraph there a little bit more. So,
It is weird how it is applied, yes.
okay, well, let's see. Enabling audio stream caching for Windows. With the project open from the main menu, select edit project settings, blah blah blah.
It's just enabling the stream caching.
Yeah, determining the right cache size. Max cache size is a hard limit for memory used by the compressed audio data, with the exception of headers and sounds explicitly marked to stay in memory. When a cache is too small, sounds will be unloaded too quickly, causing latency when loading sounds. They're they're talking quite a bit about use of cache and stuff like that, which is correct.
Yeah.
Again, I'm with how they're handling cache, you know, you know, I'm assuming that what cache is all about yourself, right?
Yeah.
Okay. And for those of you that don't know what we're talking about here, so typically you have the CPU, right? It's trying to process everything that kind of goes through it, from the computer. It's taking in data from maybe the graphics card or some form of logic, or like, hey, I move a mouse and it needs to not only process where that mouse is moving to, but tries to change where that cursor is moving, so on and so forth, right? So before they were able to actually add cache, like either like, well, not necessarily directly in the CPU itself, but I mean close to it. The CPU could only access the RAM to get very quick memory, so that it could do calculations. It would go to the RAM, it would send some equations to it or whatnot, to process what it needs to process. The RAM would send back the necessary information back to the CPU, and the CPU would respond, accordingly, right? But they noticed the fact that, RAM was, still fast. It wasn't that fast because it still had to kind of, um, send information back and forth to the RAM. So, it wasn't, there was still a little bit of time difference there. Not a whole lot, but still, some time difference. So what they did was they added memory like directly into the CPU itself, or cache. So the CPU would, if it had, very small calculations that it needed to handle, like if it's like multiplying numbers or something like that for some reason, right? Then it would just go to the cache, do those calculations quickly, and then come right back. Okay, it was just like, it's like you have your, your desk, with your computer, you're like typing everything in, and maybe you have like a laptop or something like that. Now, RAM would be like the laptop in like the next room over or something like that, right? You'd have to like get up from your desk, go to the other room, do the calculation on your laptop, come back to your main desktop, and finish off your work there. That's kind of what, analogy for like what the CPU would to go to the RAM to come right back. Cache would be like that laptop would be like right next to you per se, so you can just kind of go, oh, I need to do this calculation right over here, and then right back. Now, obviously, the cache isn't nearly as large as the RAM, in size. But obviously they're still, expanding that more and more as you continue on. And that's why, I look at this pack file, I'm like going, typically you don't have files when you're referencing anything concerning the cache on the CPU. So that's why, that's this right here, the end of the pack file doesn't make any sense to me. You're not, the cache doesn't really work with files per se. It just works with memory. It works with, bits for the most part, and that's it. That's all it does. There's not enough room in the cache to really deal with too much more than that, right? So, so here where it says the max cache size is a high limit for memory, I mean, yeah, the cache, is only very small memory, like 256K, yeah, that's probably about, 256 kilobytes, and that's, that's around the size of, some cache in certain cases. So, obviously they're working on expanding that more and more, getting more, a larger size on the cache in the CPU, but it's not exactly, when you're talking RAM, you're talking like gigabytes in size now, right? Where cache is kind of getting more along the lines of like megabytes in size, and that's about it. Is that what's meant when they speak about L1, L2 cache? Yeah, exactly. L1, L2 cache is exactly that kind of memory in that CPU. So, obviously when you have more L1, L2 cache on your CPU, the faster your CPU would run. It's not necessarily going to your RAM in order to, take care of something. So it can just go to the L1, L2 cache, do its quick calculations right there, and it comes right on back and handles everything. So yeah. Now obviously you can't say that, the cache is going to be the same size as the CPU cache, because then you're basically dedicating the entire like L1, L2 to your game, which you might have a little bit more problems with, like your operating system, for example, right? You know, uh, like it might have some problems with the graphics card or your mouse or your keyboard or something like that. If you're taking up all the cache, just for one part of your game, then, or, just for this audio, it's like probably not exactly the best idea. But again, I don't know what they mean by, cache in this particular sense. Are they actually talking about L1, L2 cache in this? I don't really know. I'm assuming Blackheart that you're probably not.
I'm not
We
sure
can
either.
assume maybe. We can maybe assume that it might be, L1 or 2 L2 cache, but you know, um, but maybe they have their own. Um, Maybe they do their own kind of cache um, in the engine itself. Maybe,
I
I don't know.
wouldn't know.
Not sure. So maybe the engine itself tries to talk with the CPU and say, hey, maybe give me a little bit of that cache to handle this work that we're doing. But you also have to be kind of careful with that, because if the CPU itself doesn't have said cache, then you might be dependent on, what, hardware limitations on a person's computer. So it might be a little dangerous for you to make the assumption that everybody's going to have, that kind of L1 to 2 cache too. So I don't know. Hard to say. Um, but if your cache limit is set to 8 megabytes, chunks are a maximum of 256 kilobytes each. So you could have 32 chunks in your cache at any time. This means that you're playing 32 sounds at once. No more chunks can be loaded. So, I would guess that's why games have minimum hardware requirements and are recommended. Yeah,
Pretty
indeed,
much, yeah.
there that should indeed. So, um, but obviously, if you're working on a game, um, you're gonna want to make sure that if the player doesn't have like the best, you're gonna want to try to you're gonna want to try to design the game for like the worst possibility of hardware you can, if possible anyway. And then work on trying to build up for like um like make sure that the game is runnable on the worst hardware, and then you work on what improvements that you can do to the game with like the best equipment that you can go with, right? At least one would figure, you know, if you try to design a game that works on just the best equipment out there and that's it, then well, uh, good luck on having any kind of player base on that. you know, like like if you design a mobile game and you're designing the game to only be used on like the best phone out there, like the brand new iPhone or whatever, right? That has all the memory and so on and so forth, but it can only be run on that, then, well, you're going to have a very limited player set.
Yeah. When
You're
developing for
not going to be,
PC, you gotta make it as accessible as possible.
yeah. Well, I mean, you're going to have to understand the fact that, you are designing a game that could be that can be so hardware intensive that you're not going to be able to allow for a lot of players to be able to play your game. Um,
Yeah, for example, games
so,
made in the Unreal Engine 5. Not everyone can run that thing. I can
so
barely run Unreal Engine 5.
um,
So games made on that aren't accessible to me.
um, there was one game back in the day that was so um that when it first came out, hardly anybody could play it.
Crisis.
Um, Crisis,
Yeah,
yeah, that
that
was
game,
that was.
hardly anyone could run it. It was so demanding on the hardware.
Mm-hmm. Yep, that was the one. Um, so you know the because that game, it's like, sure, great, you just created a game that might look fantastic. Problem is that you might only have like 10 players that can play
Yep,
it. Or something along those lines. So it's like,
a very small
okay,
player base.
yeah, so it's like, sure, you might have like a fantastic game. You might have something that you know blows everything out of the water, like it, graphically, sound quality, uh gameplay quality, like everything is just, you know chef's kiss kind of, you know it's so, you know um it's like top quality on everything, right? But here's the thing, you might only have like a few people out there that can actually run that game if it's that heavy.
Yeah,
So it's like, you know so you're kind of, obviously, when you're considering game development, you have to take that into consideration, right?
yeah,
you know um like if you're trying to design a child's game, right? Let's say like you're trying to build a game that's great for the small kids, like 5 to 10. Like you're trying to design a game that's good for like the 5 to 10 year olds, 10-year-olds kind of thing. Super easy, but meant to be kind of super cheerful, or whatever, right? Meant to be fun. Well, if it is you know extreme in the gameplay, the music, the graphics, and so on and so forth, you know 5-year-old, is going to be like going, ooh, I want this game, I want this game, I want this game. And the parents are going to be like going, we can't run that. There's no way. You know. So, you have to understand, what can and can't be run.
yep. The hardware
So,
limitations.
yeah. So, a less extreme example. Now assume your cache limit is set to 16 megabytes. This would allow for 64 and 256 chunks in the cache. If you're playing 32 sounds at once, you have room to prime 32 more sounds. However, if all 32 sounds you are playing are long enough to be in multiple chunks, the next chunk in sequence will stay loaded into the cache automatically. This means that any sound you try to prime during this time will be stomped by the 32 chunks that are loaded in advance of your 32 playing sounds. So, um, on the opposite end of the spectrum, I played Atari games, specifically football, 3-on-3, players look like blocks. Exactly. Exactly. So, when you have like, solid, blocky, graphics, such as the old Atari games, then, you know, you're not going to be expecting, you know, you're not going to be expecting a huge beast of a computer necessary to run said games. Like, those old Atari games probably still can be easily played on your phone. Easily. Um, I know, like for example, nowadays they've been able to put like the old Atari joystick. If anybody's kind of curious, look up the old Atari joystick. Um, and nowadays they are able to put so much into that old Atari joystick that they are like putting like 200 games into the joystick itself that people can play on their TV.
Yep.
You just plug that controller into your TV and it runs all those games for
Yep.
you.
Plug and
It's
play.
like so that or subtle. I don't know like how much games that they've been able to plug into the that joystick nowadays, but
Oh,
it's
you
like
can
200 games or
load.
so.
Oh, nowadays you can load a crap ton of them, but they tend to like put duplicates of the games to like fill in the blank instead of going for more variety.
Yeah, yeah.
Like I
So
said, this has 2,000 games in it. Okay, 200 of the games are uh yeah unique, but the rest are just duplicates of the first 200.
yeah, yeah. So
Unless you hack
um,
it and you edit the games that are in it.
obviously back in the day when Atari was first coming out, the hardware, the memory, the CPUs and so on and so forth, they were really small. Okay, you know, kilobytes, megabytes were like the big thing back then, right? So um, so obviously those cartridges were the games back in the day because that's all that you could kind of fit inside those memory slots and stuff like that back in the day. But nowadays, we've gotten so advanced that now, the size of the old kilobytes are now, gigabytes in size now. So it's um, just doing that kind of comparison, now you can load in like all these games into that hardware. So, but yeah. A normal example. If your cache limit is set to 32 megabytes, it can contain 128 elements, each at a max of 256 kilobytes. If you're playing 32 sounds at the same time, you still have 96 additional chunks of audio you can keep in the cache to avoid latency. If your limit is 48 megabytes, you have room for 192 elements. And so even if you play 32 sounds concurrently, you can keep 160 chunks primed. So you can just kind of swap in, if you need to prime up some additional sounds, you can kind of do so. So it's a kind of a good way of, um, handling sound that, might need to be um, set up like early kind of thing. Like say, you have music being played right at this moment in time. Like, you have the background music. It's playing, so you're listening to that, right? But like you get into a tank and you start, you're about ready to like start up the engine and start driving, right? Well, maybe you need to prime like the tank engine starting. You need to, prime up the engine running, and then you need to prime up, the sound of the treads turning, as you're moving forward, right? Or moving back or whatever, you know. So, so now you're, potentially priming up those sounds to be played at the same time as your background music. So, of course, if you're taking up all your space and cache, then well, good luck with that. Um, but yeah. Um, Obviously, the more cache that you can provide, the best. you know, you know, you're gonna be great with that, but at the same time, it obviously is dependent on the hardware as well. Um, so, here's where you can set up the cache that you can do, but they say that the max cache size is 2,147,483,647 megabytes. So, that's quite a bit of size there.
Yep.
So, yeah. Avoid latency latency by caching sounds in time. Ideally, sounds are always in memory by the time they play. This can be achieved by the following ways: permanent sound for playback. So you anticipate that a sound is going to play in the near future, you can call prime sound for playback and for playback in blueprints. Or you can use this particular command in C++. So here's the way through blueprints. That's the way through C++. Okay, good to know. For example, in an open world game, if vehicle sounds and radio stations are loaded into the cache when the player comes within a few feet of a car. If the player does not enter the car, the sounds remain in the cache until they are eventually released. Sound cues can also be primed, but no delegate fires when loading is complete. A delegate is a class that wraps a pointer or reference to an object instance. A member of that object's class can be called on that object's instance, and that provides a method to trigger that call. Okay. Setting the default loading behavior for a sound. If you expect sounds to play shortly after they are loaded, you can set the loading behavior of a sound wave to prime on load. You can also set the sound class loading behavior for a sound wave to prime on load. So, okay. Okay. I get what they're trying to basically say. So if you're like, if you're expecting that you're going to be needing to have this sound go off like immediately, like maybe you want some music going as soon as you enter a building or something like that, then you might need to put it as a primary, right? So maybe you need to switch off from like one music track to another music track. So, you might just say, hey, prime this next music track in to be loaded, where the other music track we're probably going to be, removing, or, saying, hey, we're going to need to cut you off at this particular moment in time. Or something, I'd say. Keeping sounds in memory. If a sound must play with zero latency under any circumstance, it can be useful to keep it in memory for a full duration of the used sound wave lifespan. Okay. Forcing a sound wave to stay in memory. When you set the loading behavior for a sound wave to retain on load, you set that sound first chunk of audio to live in the cache forever. So, for example, maybe you have like the gun sounds. Like you always have your gun drawn, right? Well, you're not gonna want to like remove the firing of that gun audio back in memory, or unload it, because what happens if the player like shoots like right then and there? So you might want to have it like prepped, for that particular moment when the player like hits the mouse button, then suddenly, you know, the gun goes off. So you might want to kind of keep it there, maybe. Forcing all sound waves below a certain threshold to be inlined. Okay. And stream caching is enabled. The stream all sound waves longer than setting can be used to force any sound waves shorter than a specific value to stay in memory. This is useful if you want to guarantee that short sounds, such as UI and gunshots, will play without latency on their first play without having to check and test individual sounds. Okay. When streams all sound waves longer than is set, sounds lower than this duration can still be opted in streaming using the fourth streaming checkbox on the sound wave. Okay. So
Useful for some random sound effects, I guess.
Well, it might be like, you know, like this, like they said there, you know, like gunshots, right?
Yeah.
You know, you might want to, like keep that in, you know, keep that set within the cache, right? So, so not to really get rid of it. So what you can do is you can set, you know, the duration. So like if a duration is longer than the sound itself, then it will kind of keep it within the cache so that it can be used at any particular moment in time, right?
Yeah.
So it might be useful for if you know that certain sounds are always gonna, you know, could potentially be used at any moment, right? Like say you hit the start button, or you know, you pause the screen, you pause the game, right? And you maybe have a pause sound that happens. Like you hit this, you hit the start button, you get the pause menu. You have like the pause audio, or like I remember for like Warcraft 3, whenever you paused it, it would have the pause menu would kind of drop on down, and it would have like the sound effects of like some, you know, mechanical wheels kind of cranking to kind of lower the menu down, right?
Right.
So you might need to have that in your cache, because you never know when the player might pause at a given notice, right? You know, if they pause and you're in that particular sound effect isn't in your cache, then it might take a little bit of time to get it and load it in to play it. So there might be like a little bit too much of a delay there. There might be too much latency.
Depending on the hardware, yes.
Right. So, you know, the graphic might happen, but the audio might be very delayed, you know, kind of thing. So having those sounds in cache might be, you know, useful for you. But again, you know, memory becomes kind of problematic on that too. So trimming memory. If the application requires more memory, you can release unused chunks of audio from the cache using the trim audio cache function. So if there's something like you feel like there's you're no longer going to be using a weapon, you know, for example, like, hey, let's for example, let's pick one of the like first-person shooter style games where you can kind of swap out guns, right? Like, I'll just pick one random one, like Apex Legends or something like that. You go out, you pick up one weapon that has a certain sound effect to it, whenever it's firing, whenever it's like reloading, and so on and so forth, right? But then you run out there and you find a different gun that you want to use, so you drop your one gun and you pick up the other gun, right? Well, the audio sounds for the first gun you don't really need anymore. If that person just dropped that particular gun, then you might not need those audio sounds anymore, and therefore you can just probably go ahead and trim out that particular audio cue, those audio files, because you're no longer going to be needing them to be used at that particular moment in time, right?
Right.
So
I think a better example would be Warframe. Like when you're in your orbiter, there's no gunshots, no swinging your blade, so those sounds are not used. So it would make sense to get rid of those and only load them once you enter a level.
true, true. Same kind of style too. So, and then once you're done with the level, like you go and you enter the ending screen where you show like all the members of the squad and all the resources and stuff like that you get in Warframe, right?
Yeah, it just trims all the gun and blade sound effects and leaves
Right.
only the essential ones, which is just running and jumping.
Yep, pretty much. You keep the running and jumping still loaded because you're still going to be using that when you go back to your ship, right?
Yeah.
Um, but obviously, guns, weapons, don't really need to worry about that audio anymore.
That just gets trimmed.
Yep. So, trim audio cache function iterates through the cache and frees chunks that are not in use until you reach the amount specified by the in megabytes to free argument. The function returns memory that is freed successfully. Called from C++, this function is thread safe. However, keep in mind that it locks the cache and is potentially expensive. This means that streaming audio may overrun while the function is running. So
Blueprint may be a better option then in that case.
Well, I mean,
you will have more control over the cache on the Blueprint according to this.
Yeah, a little bit, probably. So, but I mean, the blueprints are still technically C++ anyway, so, I don't know. I don't know what they're kind of talking about here, per se. Why is blueprints different than C++, but whatever. We'll have to worry about that later, I guess.
Yeah.
Monitoring the stream cache. You can type stat audio streaming into the console to toggle the cache display. And oh my god! Look at that. The stat audio streaming command displays the chunks of audio currently loaded into cache from the most recently used to the least recently used. So obviously, the ones at the very top are the ones that are being used like right then and there, whereas the ones down at the very bottom are the ones that, might have been used, but could have been a while ago, So, chunks in display are color-coded. Blue-gray is chunk is loaded but not currently playing. Green, chunk is currently playing. Red, the chunk has been deleted by the call to trim memory. So, and this is a little problematic because I don't see any red in this screenshot. I see a lot of green, which means that there's a lot of sound bites that are being played all at the same time right at this moment in time, and these are different sounds, by the way, that is playing. They're not, the this isn't the same kind of sounds that are being played. Otherwise, that would be a little weird having the same sound that's loaded into the cache being played at the same time. So, that might be a little problematic if you're seeing like the same audio file being played in two different instances even in your cache. That might be a little problematic. I would say.
Yeah.
Uh, but I mean, each one of these should be, something that um, uh, very, especially the ones that are green. You shouldn't see any duplicates in there. Although, it makes me wonder because I look at this and I see the ones that are, you know, in the blue gray. Um, like here, let me see if I can maybe uh, open image and new tab. So that's not really. I hope everybody. I don't know if anybody can really see it because uh, my webcam might be in the way. But okay, maybe like I'll look up here. You have this Seattle VAR 29. Um, the name is the same there, right? So that's typically the same audio file, but one is not really loaded and not playing, whereas one is playing, but they're the same file. So not quite sure what's going on here.
Do take consideration the order. Like the lower it is, the higher it is, the sooner it's been used. So it was used, and then it stopped being used, but it is still loaded in.
True.
Like say
True.
you took one shot. Okay, it used and then immediately it stopped using because you only took one.
True. Okay. Yeah. I can see that now. Hmm. So in other words, in this particular case, there's no sounds being. Well,
Right? That's what it's saying. It's like, okay, I played the sound and then I stopped using it. Then I play another sound and I stopped use that sound. Then I played another one and stopped using that other one.
But here's hmm. It's a little odd because you know they're showing a lot of information here about this is screen, this is currently playing. So shouldn't they like not be showing all these screens anymore if they're not playing anymore? That's what kind of strikes me as kind of odd. You would think that once it's set to the blue gray, then it should like remove the green. You would think, but then again, maybe they still want to show that information for data anyway, like how often it got used, maybe. I don't know. Kind of curious about that.
Yeah.
But maybe we'll find out more about that later when we get to that, like maybe this will help us, yeah, that's showing all these screens, but maybe that will help us in the future for like debugging sound cues or something like that. I don't
Probably.
know.
Hi there, Galaxy Girl. How you doing? Long time no see. It
So,
sure has been some time.
uh, let's see.
I was not entirely sure like how much of this we're gonna use after it says that this is mainly used on like open world games, not so much on other genres.
Well, I don't know if it's, strictly
It's not
for
strictly,
open
but it's
world.
most
So,
commonly used for that.
um, um, it's just, um, it's popular for open world games, but it doesn't. You can still use it uh, for other games as well. That you might need to have. Um, you might need to access the memory, the audio at moment's notice, kind of thing. You know, uh, mm, like the RTS that I was talking about, like dropping down the menu system. You know, that's not necessarily an open world game.
No.
So I can see it being used in other style games as well. Yes, definitely open world games definitely does um, come into play on that one. But, obviously there's other applications they could use with it. So, okay. I think that's where we're gonna go ahead and call it. The rest of it is, feels like it's a little bit more niche in
Yeah.
terms of like what you can kind of see and use it for. So I think we can probably skip the rest of that
Yeah, it
for the
seems so
most part.
too.
Um, so I say maybe we'll skip the rest and we'll move on to submixes tomorrow. Sound
Sure.
like a plan?
Yeah, I think that sounds like a good plan.
Okay. Okay. I just wanted to kind of get your take on it. If you want me to, I can keep on going, but we're
No.
already at the 3 o'clock mark, so
Yeah, I need to go get some food.
yeah, yeah. And you're gonna also be doing Genshin or
Honkai.
Star Rail
Yep.
tonight?
Yeah.
Okay.
Got a lot of side stuff to finish off.
Yeah. Yeah. I need to find out what I missed. So, so Unreal Engine. What language is it? They they have their own. Well, I mean, they have blueprints. That's their own kind of, I guess, language, scripting language per se. But obviously, you want to have a C++ background with
Yeah.
Unreal Engine.
Yeah.
So,
Blueprints makes
um,
it easy for anyone that doesn't know coding. Well, for those that know some coding, they can use the C++ programming
yeah,
language.
yeah. So, I don't know how much you can get away with building a game with just blueprints itself. So you might have, it might not work completely with blueprints. But again, I don't know. Me and Blackheart are new to Unreal, so I mean, we haven't even gotten into really using blueprints all that much anyway.
No.
So,
I'll probably catch it
um,
once we get to the more practical stuff.
yeah, yeah. So we'll see it at some point in time. So I'm sure, if I'm not mistaken, there are, you know, sections like concerning blueprints directly, that we could probably go to, but yeah, we'll worry about that a little bit later. So,
Yeah.
all right, well, that's gonna be it for today's uh, Unreal study session. So, um, I've taken C classes 10 times in my life. This is why I chose not to be a programmer. I mean, I hear you on that one. You know, the C language can be very, very daunting. Um, Especially when you get into pointers and memory management. Believe me, I know, you know. Um, but um, you know, I tend to uh, yeah, I mean, there's a reason why a lot of games like to use C++ and as a programming language because of its memory management. So it can be very, very fast when it comes to, you know, being able to set memory, use memory, and release memory. But there's also the downside of if you don't release memory properly, then you start causing problems. So, um, and that's why a lot of, that's why, you know, you have problems that sprung up that people are like going, I can't deal with this. You know, I'm going to go to Java with their garbage collection. So, um, but bear in mind, how many games out there are based off of Java?
Not many.
Yeah,
They're not. They're normally
not,
C++ or C sharp.
yeah. So, just pointing that out. Not to say that there you can't program out a game in Java. You can definitely do that, but you're not going to be looking at typically a lot of people don't really like doing game programming in Java because it can be still kind of slow in its memory management. And obviously, when you're talking about a game and you're talking about something that needs to be very, very fast, like a first-person shooter, well, Java might not necessarily cut it
No.
very well. So, not to say that you can't do it, just saying that it might not be typically regarded as the best first-person shooter game out there. Just saying. So, um, but yeah, but that's going to be it for today's Unreal Engine study session. We're going to continue this again tomorrow, so look forward to that. I want to thank everybody that was here chatting with us. I personally want to thank Dad Shoes for stopping on by and chatting with me in my chat. Blackheart, do you have some people that you want to shout out?
Oh, there's Galaxy Girl there.
Oh, okay. You wanted to shout her out. Okay.
Yeah.
I was kind of wondering if you did or not, but I wasn't too sure. Um, but I want to also thank anybody else that was just in the background watching.
She says hi.
And enjoying. Yeah. Um. So anybody that was just kind of lurking in the background, want to thank you all for being here as well. Hopefully you enjoyed these little study sessions that we're doing. Hopefully you found it informative and enlightening. Again, if you feel like we're missing something or we got some things wrong on this particular topic, then obviously either come to our chat and let us know, or put it into our comments when we upload these to YouTube. So feel free to do that. We're always welcoming of constructive feedback, as long as it's constructive. And yeah, we'll keep on pushing forward on this. We got goals in mind, so we'll get there. But obviously, first thing that we need to do is actually learn the material. So
Yep.
All right.
Alright.
So let's get out of here, my friend.
Yep.
You go get your food. I need to use the restroom. I'm gonna go stop the recording. So take care of that, everybody. Have a good night.
Bye bye. Okay. I'm going to
All
go
right.
get some food right now. So,
Sounds good, my friend.
okay.
All right. Bye.
Take care. Bye. Okay, there we go. And let me check that thing you said there, Galaxy Girl, before I go. I just didn't want to put it while the Discord was on because I didn't want to bother Jim with that. And what the hell? 5019 on French? What is this supposed to be? I'm gonna run it.
50-19.
That's a creative way to say it. I guess now we have a way to maybe troll other streamers, just tell them to do that. Maybe do that just in try out something. Mike? Why? And my friend's gone all squeaky. Anyways, I'm gonna mute my desktop just in case. Never mind. Anyways, it's sauce. I don't know how it is sauce. But anyways, I need to go get something to eat before I start my Honkai Star Rail stream. Or I'm gonna end this one. I don't like eating on stream. Not even if I put on BRB. I just don't like having it that way. So I'm gonna get some munchies, and I'll be back in about an hour, maybe. So I hope you enjoy this stream. Again, if you all have any advice or maybe you can explain something that we misunderstood, leave it down in the comments below. And I hope to see you all in a little bit. Bye bye!